Hello there, my name is Aiden Stark. In this video, I will be demonstrating the robot's ability to track a green block and always adjust its heading so as to face the green block. First, to describe how it achieves this, I have a camera mounted to the front of the robot, in which is looking at the green block. Through HSV color masking, that green block is masked out, and then using OpenCV's bounding rectangle, I find the bounding box of the rectangle and the location of the rectangle in the image that encapsulates this green block. And then also looking at the pixel coordinates of the center of that block with respect to the center line of the image, I'm capable of determining how many degrees this block is to the left or right of the image, since I know the FOV, the field of view of the camera, along with how many pixels across it is. And so I can determine how many the degrees per pixel of the camera, so as to determine how many degrees the block is based upon the pixel value it is within the image. So, but in order to actually turn facing the block, the robot does not pivot at the camera. It pivots at the center, over here, in the middle of all the wheels. And so, in order to determine the correct pivot distance for the robot, I have to take into account both that angle with respect to where the block is to the camera, also get the distance to the block, I'll discuss that in a second, the distance from the camera to the center, and then use that to trigonometrically determine what angle the robot needs to twist in order to get to the block. So that trigonometry is how I determine the angle for the robot to turn, so that the robot is facing the block based upon the angle between the block and the camera, and the distance from the block to the camera, and the distance from the camera to the center point of the pivoting. As to how the distance to the camera's block is captured, I've calibrated it such that by taking a series of experimental measurements of the block's height and widths at various distances, I developed an equation in which will then fit each block's height and widths to correlate to the distance. All right, now I'll test out and demonstrate it for you. Regarding the oscillations, you may sometimes notice that for larger movements, such as that you'll notice that it seems to stop at a midway point before going to the target. This is a result of the capture frame rate. For very large movements, it may take a picture as I was mid-moving. It's not continuously updating from a live camera stream. It takes a picture, does all the math, and then determines how much it needs to rotate. So for a large movement, it may take a picture, move to where it had been mid-motion, and then re-update the frame and continue moving. As for the little pivots at the end, that is it adjusting if it is not within the threshold and it kind of overshooting as it corrects itself. All right, that is my demonstration. Thank you.